So this is number 94 of Unit 5. It says, use your derivative tools to differentiate each function. Now, some of the derivative tools or the deriving tools that we've learned would be product rule, chain rule, quotient rule, and the power rule. So let's start out with A. Okay, so derivative of sine x plus 3 to the cubed root. Well, I like to write this guy right here, x plus 3 to the cubed root, is equal to sine x plus 3, parenthesis, to the power of 1 over 3. It just makes more sense to me. I really like the way it looks better, but if you don't like that and you like to use this one, more power to you. But just keep in mind that this is equal to this, and this is equal to this. Okay, so cosine, we want to take the derivative of this guy, right? Cosine x plus 3 to the power of 1/3. Right now what we're using is the chain rule, I believe. No, yeah, chain rule. So this guy right here times 1/3, right? Because we want to pull down the 1/3 in front of x plus 3, right? The derivative, the outside derivative times the inside derivative. 1/3, and then x plus 3 to the power of negative 2 over 3. Now, if you're wondering how I found negative 2 over 3, that's just 1/3 minus 3 over 3. When 3 over 3 is basically equal to 1. So I should get negative 2 over 3. Very nice. So there's that. But hold on. What about the derivative of x plus 3? X plus 3, the derivative of that is just equal to 1. Now, I don't have to write times 1 because that's not necessary. But if you want to write that, go for it. Showing more work is always good. All right. Now, this right up here, what I have is correct. But what you could do is you could rewrite it as some people would do. If you did not make this change right here, and let's say you kept it like that, you would write it as cosine x plus 3 to the cubed root times 1/3 x plus 3 to the power of negative 2 over 3. That's how you would do it. All right, moving on to B here. Let me push the packet out of the way. Moving on to B over here, the derivative of 4 minus x squared over x cubed minus 2. Okay, so let's think here. The derivative, let's think here. What kind of rule? Oh, we are going to use our little buddy called the quotient rule. So the quotient rule, I like to remember as bottom d top minus top d bottom over bottom squared. So d meaning derivative, right? I'm going to keep him over here because we're probably going to use him later. But let's take a look at this guy. So if we remember bottom, which is x cubed minus 2 times d top, derivative of the top. What's the derivative of this guy? 4 minus x squared. We're going to bring down the 2 here. The derivative of 4 is 1. Bring down the 2, 2x to the power of 1. Negative 2x. Minus. Remember the minus. You always remember the minus because it's quotient rule, not product rule. The top, 4 minus x squared times the bottom. There we go. There's the bottom. Derivative of the bottom. Derivative of this guy is we're going to bring down to 3x squared. There we go, just like that. And the derivative of negative 2 is just 1. So we are left with this guy. Now, technically, this is correct, but we want to simplify this because we like it better when it's nice and simplified, right? So this one is negative 2x to the 4th, right? Plus 4x minus 12x squared plus 3x to the 4th, because I just distributed these numbers into these numbers, right? So after doing that, I want to combine my like terms here. So I've already boxed all my like terms to make them nice and different, and I can see them very easily. And I'm going to get negative 2x to the 4th plus 3x to the 4th gives me x to the 4th. I'm left with minus 12x squared, plug that down here, plus 4x, push that down here, over x cubed minus 2 squared. And that's my bottom squared. And this right here is the correct answer. All right, cool. So moving on to C. d over dx. 1 over cosine x is equal to cosine x times 0 minus 1 times negative sine x over cosine squared x. Now, I am using the quotient rule again. Remember, bottom times d top minus 1, bottom times d top times, or minus, the top times d bottom over bottom squared, right? So cosine, which is the bottom, times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom, which is negative sine x, over the bottom cosine squared x, over the bottom squared. So I'm going to simplify this guy out. Cosine x times 0 is 0. We don't need that. Minus 1 times negative sine x. Now remember, negative and a negative cancel out, so we get a positive sine x. So now we have sine x over cosine squared x, which is equal to sine x over cosine x times cosine x, which is equal to secant x times tangent x. Now what's interesting about this guy right here is actually a trigonometric derivative. Now a trigonometric derivative is just one of, I believe, seven that I have here. Now I recommend that you memorize these because we already know a couple of them. I mean, look at that. Sine, the derivative of sine is equal to cosine, and the derivative of cosine is equal to negative sine. And we just figured out another one on the back side. So if you can memorize these are actually really, really good to use, and they'll probably show up a lot. So you can pause the video, use those, and yeah, that'll probably be good. Okay, so let's see here. Number 94D, the derivative of 6x minus 1 times sine 2x. So 6x minus 1 sine 2x is equal to 6x minus 1 times cosine 2x times 2. So what we're using here, we are using the product rule. Okay, so product rule. The first, 6x minus 1 times the derivative of the second, sine x 2x goes to cosine 2x. Oh, hold on, chain rule. So first derivative, okay, so we're going to take the derivative of the outside here, which is sine cosine 2x times 2. We're multiplying that by the derivative of the inside, 2x, right? So derivative of 2x is equal to 2. Plus, now we want to take the second, sine 2x, that's easy enough, times the derivative of the first. Now the derivative of the first is 6x minus 1, right? What's the derivative of this guy? Derivative of negative 1 is just 1. Or I'm sorry, derivative of a constant right here is going to be 0. And then we have 6x, right? Well, derivative of that is going to be 6. So we got sine 2x 6, right? And if we, right now, this right here is correct. But if you wanted to write that more correctly, I guess, you would take these coefficients or the constants, and you'd stick them in front of everything else right there. See that? 2 times 6x minus 1 cosine 2x, which is just the same thing. 6 and the sine 2x flip-flop, and we get 6 times sine 2x as opposed to sine 2x times 6. Basically the same thing. All right. Moving on to E. Woo, we're almost done, guys. All right. Sine times 3x over 2x cubed. What are we going to use here? Quotient rule. All right. So 2x cubed, right? Remember our quotient rule is bottom times d top minus top times d bottom over bottom squared. So bottom, the bottom is 2x cubed times d top, the derivative of the top, which is going to be cosine 3x times 3. Remember, we have to use the chain rule here. So derivative of the outside, which is sine, or I'm sorry, the derivative of sine is cosine, there we go. And then the derivative of the inside, 3x, which is equal to 3. There we go. Minus, now we want to do top times d bottom. So what's the top? Sine 3x times the derivative of the bottom. Now the derivative of the bottom, we're just going to do this here. Use the power rule to x cubed. Drop the 3 down. We get 6x, and then we subtract 1 from the exponent, 6x squared, right? That's what we have here, 6x squared. Over the bottom squared, 2x cubed to the power of 2, or 2x cubed squared. Okay, or 2x cubed quantity squared. There we go. Okay, moving on here. So what you could do actually is you could simplify this guy down to get this answer. But this up here is technically correct. But if you wanted to simplify it, all you would really have to do is you could distribute these, which is 2x cubed, right? Distribute it into this one, and then 6x squared distribute into this one, and we get 6x cubed cosine 3x minus 6x squared sine 3x over, right, 4x cubed. We want to plug in the 2 here, so we get, what do we get? We get 2 times 2 is 4, and then we get this one here would be 6, right? 3 times 2 is 6. Okay, so we get 4x cubed to the power of 6. And then you can simplify even further to get 3x cosine 3x minus 3 sine 3x over 2x to the 4th, or to the power of 4. All right, so moving on to the final. F for final. All right, our last question here. Almost done, guys. So the derivative of the square root of sine squared x plus cosine squared x. So like I said earlier, I like to rewrite this as sine x squared, right? Because sine squared x is kind of a weird way to look at it, plus cosine x squared. Again, cosine squared x, I don't know about that one. And then I'm going to put all that in parentheses to the power of 1/2. All right, that's just how I like it. So let's think about this one real quick, actually. The power of 1/2 and squared, well, don't these guys just cancel out? That's right, they cancel out. So I get derivative is equal to sine x plus cosine x. Well, hold on now. Sine x plus cosine x is one of our trig identities, and that is equal to 1. And now what's the derivative of a constant? 0. There's your answer. All right. This has been question number 94. It's been a long one, but thank you guys so much for watching, and I hope this helped. Bye-bye.